The diagram above shows the curve with the equation y squared equals 4 times x minus 2, and the line with the equation 2x minus 3y is equal to 12. The curve crosses the x-axis at point A, and the line intersects the curve at the points P and Q. Part A, write down the coordinates of A. Well, A, this point here, I know that y is equal to 0 at that point, and I know that this curve passes through that point. So if I make y equals to 0, y squared will be 0, and we'll go 4 times x minus 2. So therefore, divided by 4, x minus 2 is equal to 0, and x must equal 2. So the coordinates of point A are 2, 0. Part B. Find the coordinates of point P and Q, which is where our straight line intersects with the curve. So we're going to do simultaneous equations here. So my curve, let me just write that down. Y squared equals 4. I'm going to expand the brackets. 4 times x, 4 times the minus 2. And I'm going to just rearrange this straight line slightly. I'm going to say that 2x is equal to 3y plus 12. I've just added the 3y to both sides there. And the reason why I've done that is just to make the simultaneous equations a little bit easier, because I could relatively easily times that second equation by 2 to get 4x is equal to 6y plus 24. And now I can write this instead of the 4x here. Obviously, lots of different methods you could use for these simultaneous equations. This is just the way I'm choosing to do it. So factorising this, then we get y minus 8 and y plus 2. So y is either going to be 8 or minus 2. Substituting those back into either of the original equations, it doesn't particularly matter to get the x coordinates. I'm going to substitute those y coordinates in to this equation. So the 3 times the 8, so I'm just substituting 8 in here now. 3 times 8 is 24, plus the 12 is 36. Dividing by that 2 is 18. Excuse me. And now doing the same thing with the y being minus 2. So 3 times minus 2 is minus 6, plus the 12 is plus 6, divided by that 2 is 3. So we've got the coordinates 3 minus 2 and 18, 8. So just comparing which one's which here. Clearly the P is going to be the 3 minus 2, and the Q is going to be the 18, 8. Hopefully that's obvious just looking at the numbers and the fact the y coordinate's minus 2 for P. Whilst I'm at it, let me also put A back on here as well. Right, part C. Show that the angle PAQ is a right angle. So let me mark this onto my diagram, the angle PAQ. So we've got the angle from P to A to Q. I want to show that this is a right angle. Well, the easiest way to do that is to show that we have the two gradients that multiply to make minus 1. Right angle means perpendicular, which means negative reciprocal gradients, or when you multiply the two gradients, you'll get -1. Whenever we want to show things are perpendicular or meeting at a right angle, this is the way you want to do it. Most of the time, anyway. So let's work out the gradient of the line PA. So looking at the P coordinate and the A coordinate, let's see the change in the Y divided by the change in the X. So we'll have -2 minus 0 divided by the change in the X coordinates. So we get -2 over 1. So the gradient of PA is -2. Let's now do the same thing with the gradient of AQ. So just looking at the A and the Q coordinates now. Again, change in the Y coordinates. So 0 minus 8 divided by the change in the X coordinates, 2 minus 18. Is equal to -8 over -16, which is positive 1/2. And so, if we multiply those two gradients together, we do indeed get -1. Therefore, PAQ is a right angle.